Hello Honors Geometry students, this is our third and final day of talking about transformations. Today we're going to be talking about a specific type of transformation known as a translation. Now when we refer to a translation, what we're really talking about is a slide or a movement. If you look at this picture over here to the right, what I'm really doing is I'm taking this triangle and I'm sliding it over here. You could think of it as a movement. I could be moving it up, I could be moving it right, I could be moving it down, diagonal, whatever. But I'm just moving, or I'm sliding this image, or I'm sliding this figure. Now when we refer to a translation, I mentioned this a few days ago, a translation is what we call an isometry. Meaning that if I move this figure, or if I slide this figure, the distance between the vertices is going to stay the same. So if I move this triangle over here, that means that the distance from here to here in my pre-image is going to be the same as the distance from here to here in my image. The distance is preserved. Now, when we talk about this, when we talk about our vertices, and when we talk about pre-images and images, let's look a little bit closer at this translation. Now, what I want you to do before we move on is I want you to kind of clarify some of these points. This vertex should be right there. Alright, this vertex should be right there. I know it's a little bit off. And then this vertex here, here, there, and there. Okay, so when we refer to the pre-image, okay, as you can see here, when we refer to the pre-image, we're referring to all the vertices in this specific figure. So that would be this vertex. We'll call this vertex A. So that's at the point negative 1, 2, 3, 4, 5, negative 1. So vertex A is at negative 5, negative 1. Vertex B, we'll call this vertex B. Vertex B is at negative 1, 2, 3, and then negative 1, 2, 3, 4, 5, 6. So negative 3, negative 6 is vertex B. Is negative 3, negative 6. And then lastly, on our pre-image, vertex C is at the coordinates negative 1, 2, 3, 4, 5, 6, 7. Negative 1, 2, 3, 4, 5, 6. So negative 7, negative 6. Negative 7, negative 6 for vertex C. Now when we look at our image, you have to look at what vertices or what vertex corresponds with vertex A. So that would be this vertex up here. So we're going to call that A prime. This vertex down here corresponds with vertex B, so we're going to call that B prime. And this vertex right here corresponds to vertex C after the translation, so we're going to call that C prime. Now, what we have to do is we have to think to ourselves, okay, how do we get from A to A prime? Okay, well, how do I get here? Well, I'm going to start at A, and I'm going to go right, 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to go up, 1, 2, 3, 4, 5. So if I go right 8 and up 5, that puts me at A prime. And A prime has the coordinates 1, 2, 3, 1, 2, 3, 4. So 3, 4 for A prime. B prime has the coordinates 1, 2, 3, 4, 5, negative 1. And C prime has the coordinates 1, negative 1. So again, when we think about translations, and when we think about writing translations in what we call coordinate notation, we have to think about how did we get from vertex A to vertex B, A prime? How do we get from vertex B to vertex B prime? How do we get from vertex C to vertex C prime? And really, it should all be the same. So just like we got from A to A prime by going right 8, up 5, we should be able to do the same thing from B to B prime. If I go right 8, 1, 2, 3, 4, 5, 6, 7, 8, and up 5, 1, 2, 3, 4, 5, that will get me to B prime. If I start at C and I go right 8, 1, 2, 3, 4, 5, 6, 7, 8, and up 5, 1, 2, 3, 4, 5, that'll get me to C prime. So when we write our translation in coordinate notation, you should be thinking, well, coordinate notation is just a way for me to write how I got from A to A prime, or how I got from B to B prime, or C to C prime. It's basically saying, how did this figure, how did my pre-image get translated to be my image? And the way we write that in coordinate notation is this. I would say x, y, and then I draw an arrow. Okay, x, y is each vertice in my pre-image. So basically what this is saying is I took each vertice in my pre-image and I moved it, this arrow means moved or mapped, and I mapped it by taking each x coordinate and adding 8, and then taking each y coordinate and adding 5. So it would be x plus 8 and y plus 5. Okay? And if we go back to our original, here's our pre-image and here's our image coordinates. Here's our pre-image coordinates and our image coordinates. What happens if I take -5 and I add 8? I get 3. Let's go to B now. What if I take -3 and I add 8? I get 5. What about C? If I take -7 and add 8, I get 1. Okay, let's go to the y coordinates now. If I take -1 and add 5, I get 4. If I take -6 and I add 5, I get -1. And again, if I take -6 and I add 5, I get -1. So this would be how we would write in coordinate notation our translation from this figure, ABC, to figure A prime, B prime, C prime. Okay, let's do a couple more examples here. This next problem says describe the translation using coordinate notation and a vector component form. So we're going to get to vectors here in a second, but let's stick with coordinate notation first because that's what we just talked about. So if I want to know how did I get from this figure, if this is my pre-image, and then the dotted figure is my image, how do I get from this image to this image? Well, what you can do is you can really pick any coordinate. Pick A, B, C, or D. Doesn't really matter, so I'm just going to pick C. And ask yourself, how do you get from C to C prime? Well, we go over 1, 2, 3, 4, 5, 6, 7, 8, and we go up 1, 2, 3, 4, 5. So we would say xy goes to x plus 8, comma y plus 5. So I go right 8, up 5. Now, what I would do is I would definitely double check it with another vertice. So let's check it with the b's. So I'm going to say, how do I get from B to B prime? I go up, or I go right 1, 2, 3, 4, 5, 6, 7, 8. Perfect. And then I go up 1, 2, 3, 4, 5. Now, when we talk about writing that in a vector component as well, okay, what a vector is a quantity that has both a direction and a magnitude. So the vector from this, if I wanted to draw the vector from C to C prime, it would look like this. Okay, a vector is basically an arrow that represents both a quantity and a magnitude. Okay, and what it is, it's represented by an arrow drawn between 2 points. Now, what's nice is we can write our answer in a vector component based off of what we wrote in coordinate notation. So the vector component, the vector is made up of 2 components. It's made up of the horizontal component, which is the x direction, and the vertical component, which is the y direction. So if I wanted to write this in a vector component, I would say I went right 8, so I would just write the 8 there, and then I would go up 5. So this is my coordinate notation right here, and this is my vector component. Alright, let's go to this next figure over here. It wants to know how do I get from this, again this is my pre-image, we know that because This is A prime, B prime, B prime. Anytime you see a prime or a little hat, a little tick mark after the letter, that means prime or new. This is our original shape, this is our new shape. So again, choose a vertice. I'm going to choose vertice A here to start. And it wants to know, how do I get from A to A prime? Well, I have to go right, 1, 2, 3, and I go down, 1, 2, 3, 4, 5, 6, 7, 8. So if I'm writing this in coordinate notation, I would be xy maps, or xy moves to x plus 3. And then I went down 8, so it's not y plus 8, it's y minus 8. And again, double check that with another vertice. So let's check, or another vertex, sorry. So let's check it with vertex C. So I'm going to go right, 1, 2, 3, and then down 1, 2, 3, 4, 5, 6, 7, 8. So again, if I'm writing that in a vector component, okay, again, my vector would be this arrow from A to A prime. So this arrow, in order to draw that arrow, I had to go right 3, down 8, so my vector component would be 3, negative 8. Alright, now, what if we don't have a graph? Okay? What if it just says a translation is defined by, and then it says xy map to x plus 2 or y minus 3. And again, what that means is it means we're taking every vertice, in our image, or in our pre-image, and we're moving it to the right 2 and down 3. So what I'm going to do is I'm going to